In this question, Muhammad has 20 meters of fence, and he wishes to put fencing around the outside of his garden. He plans to build the garden against his house, so there's no need for fence to be put along that side. So for instance, he wants to put fence on 3 sides to create a rectangle, not needing fence along that 4th side. Well, we want to know what are the dimensions of the largest garden possible in terms of area, and what is the area of the largest garden possible. Well, first thing we do is draw a diagram, and we know that this length and this length are going to be the same, so we'll label them W. And we know that this length here will not necessarily be the same as these W's because we have a rectangle. So we have 2 lengths and 2 widths. But this length here doesn't require fencing. Well, we know the area of the rectangle is length times width. Okay, that's the formula for area. And a second equation we know in terms of length and width is that the length plus the width plus the other width is equal to 20. Length plus 2W equals 20. Okay? Now, what we're going to do next is isolate the L here. And there's a reason for that. We want to eventually substitute a new expression for L into this equation. So, isolating the L, we get 20 minus 2W. So L is equal to 20 minus 2W. Now, we can substitute this new expression for L into the equation area equals L times W. So instead of L times W, we call it 20 minus 2W times W. Okay? And now what we have is a factored expression with only one variable, the W. In order to find the maximum, what we can first do is find the zeros of that factored expression, and then we can determine the axis of symmetry. And we'll then be able to determine the maximum area when we get to part B. So what we do is we let this first factor equal 0. That means 20 minus 2W equals 0, which means 20 is equal to 2W, which means 10 is equal to W. W has a value of 10 to make this factor equal 0. Well, W has a factor of 0 to make this factor equal 0. So we have zeros at 10 equals W and W equals 0. What we want to do next is add these two together and divide by 2, and that's going to give us what we call the axis of symmetry of the parabola. So 10 plus 0 divided by 2 is equal to 5. Well, what we've just established is that the vertex occurs when W equals 5. So what we do next is determine our length. We know from earlier that length is equal to 20 minus 2W. We've established the maximum area occurs when W equals 5. So when that happens, the length will be 20 minus 2 times 5, which is the same as 20 minus 10, which equals 10. And so the largest area occurs when the width is 5 meters and the length is 10 meters. And to see that on here, if the width is 5, then this width is 5, and then that leaves us 10 meters for the length, and we've used up all 20 meters of our rectangle. Now for part B, it says, what is the maximum area possible? Well, one way that's kind of easy is to say, since the width is 5 and the length is 10, just multiply length times width. 5 times 10 is going to equal 50, and we can therefore say the largest area possible under these circumstances is 50 meters squared. A second method is to go back to the area formula that we had a while ago. A little while ago we had this area formula, A equals 20 minus 2W times W. Well, if we want, we can just substitute W equals 5 into this formula and figure out what the area will be. 20 minus 2W times W, with a value of 5 for W, is 20 minus 10 times 5. And that is 10 times 5, which is 50. So whether we go by method 1 or method 2, we see the largest area in this case is 50 meters squared.